Okay, now that we've learned all about 2.2 and 2.3, solving linear equations, let's solve linear inequalities. So the biggest difference between equations and inequalities is that inequalities has a symbol that's not an equal sign. So an inequality will have either a less than, greater than, less than or equal to, or greater than or equal to symbol. Now, I know that this is not new information. I know that you've learned this in Algebra 1, but I am going to go over these symbols again on the side so we remember. This symbol here is not showing up. Hold on. This symbol here is less than. This symbol is greater than. When we add half of an equal sign, it turns into this one is less than or equal to. And then if we flip it around, that's greater than or equal to. So I know in Algebra 1 you learned all about solving linear inequalities, but basically we're going to be reviewing this and then jumping into linear inequalities and compound inequalities and then absolute value inequalities. So something that's important to note is that we have a different type of notation that you will be using in Algebra 2 and in future math classes, and it's called interval notation. So the notation involves parentheses and square brackets. So whenever you have square brackets like this, that means that the numbers are included. That interval type is a closed bracket, and that means for a less than or equal to or greater than or equal to symbol. A graph, you could use the square brackets like this, or you could also use, if we're talking about between A and B and including A and B, you could use closed circles like this to show that it is included. However, open intervals use parentheses, and that means that those numbers are not included in your answer. Like between A and B, but not including A or B would be considered an open interval because those endpoints are not included. Another way to show that is by using open circles like this. Sometimes you'll see open circles rather than the parentheses or the square brackets. Now the endpoints don't always have to be the same. You could have one closed and one open. So in the next one we could see this is between A and B, but A is included. So you could see they had a square bracket there. B is not included, so they have a parenthesis. Here's what it would look like with the circles. And then vice versa, if you have A not included, but B is included, you could also use this type of interval notation for the graph as well. So when we have compound inequalities, that's when we have an answer that's between two numbers and your endpoints are either going to be included or they're not going to be included. Sometimes we have unbounded intervals. That means that the answers go on forever. So in the next example, we have examples of intervals where the solutions go on forever. Like if we look at this inequality here, that the numbers are greater than or equal to A, let's say. We can see on the graph that it starts at A, including A, and goes on to forever to positive infinity. Similarly, if I had something like x is greater than or equal to 2, on my graph, I would have 2 here, and depending on what you like better, you can use the square bracket if you want, or you can use a closed circle. Depends on your Algebra 1 teacher and what you've learned in the past. I've always taught closed circles, and the answers would be pointing to the right because that's positive infinity. That would be considered a closed situation since it starts at 2 and goes on forever, which means 2 is a solution, but it goes to positive infinity. Now notice the notation for that uses the square bracket to start at that first number and then comma an infinity symbol. That infinity symbol will always have a parenthesis around it because a parenthesis represents something that's not really necessarily included, and a positive infinity is not really technically a number, it's a concept. So that's why we have a parenthesis there. Notice there's parentheses around all of the infinity symbols, whether it's positive or negative, and that's because infinity is not a number, it's just a concept. So depending on the situation, if you have the answers pointing to the left or to the right, you will either need positive or negative infinity. Notice when you're using positive infinity, the arrow is to the right, negative infinity, the arrow is to the left. So we'll get more into this once we get to compound inequalities. But that is just like a little refresher on interval notation. If we flip this over to the next page, let's go over some graphing inequalities using a number line and using interval notation as well. So the first one is x is greater than negative 6. This number here is considered the end point. This is the only number that I need for you to include on your graph. You could totally put 2 numbers, 3 numbers, 4 numbers. It honestly is up to your math teacher from before how many numbers you would need to put on this graph. But listen, I'm totally fine with you just putting negative 6 on your graph. You don't have to put a million numbers. This is fine. And then you need to decide what type of negative 6 this is, whether it's included or not. And you tell from this symbol here. This symbol will tell you if it's going to be included or not. Now, you can choose if you want to use parentheses. These would be parentheses for not included. The square brackets would be for included or closed. Or if you want to use circles, included circles would be closed like this. You just color them in. And not included would be open circles. It's up to you. Honestly, my whole entire math career I've used circles, so I'm going to be doing that now. If that messes you up and you want to use the parentheses or square brackets, I will totally accept it. It's not going to be wrong. It's just not something that I'm used to. And math people, we always like to stick with what we're used to. So I'm going to be using an open circle around the negative 6 because this number is not included. Now, if you were going to use one of the types of brackets, you would use a parenthesis, not a square bracket for this. And anything greater than negative 6 is anything to the right. So here's how I would do my graph. Now notice, I skipped the interval notation because I prefer to do the graph first and then end with the interval notation because I can see what's going on here better. I'm starting at negative 6 and my solutions are going to the right to positive infinity. Now it's time for me to include what I need around the negative 6. The negative 6 is going to be open, so that's a parenthesis, and parentheses always go around the infinity symbol. So that would be my interval notation for this one. The next one, x is less than or equal to 2. All I need is 2 on here. This is a closed circle because this is a solution since it's less than or equal to. Anything less than or equal to 2 would be to the left. So here's the graph. Now I'm going to come back to the interval notation. So I like to match my interval notation with the graph. The first thing that I see in this graph is the arrow here. When I read it from left to right, I see this arrow pointing to negative infinity. So you write that first. You're basically writing the numbers from least to greatest. And even though negative infinity isn't a number, it's smaller, quote unquote, than 2. So you'd have to put negative infinity first and then 2. The infinity symbols never have square brackets. They're always going to be parentheses. However, this 2 is included, so I'm going to use a square bracket here. So those are just regular inequalities. These are going to be compound inequalities. So I need 2 numbers on here. The endpoints I need are negative 1 and 5. Now, depending on what you want to do, you could really do negative 1 and count 0, 1, 2, 3, 4, 5. If you're making your own graph, I'm fine with you just making a line and putting negative 1 and 5 on there. You don't have to put all the little dashes. It's up to you. So the circle that we need around the negative 1 is going to be an open circle because if we read this inequality from left to right, it says negative 1 is less than x, which also means x is greater than negative 1, so it's not included. But we would need a closed circle around 5. And the solutions are going to be in between these two numbers, so this would look like that, from -1 to 5. For the interval notation, I know that it's going to be -1 comma 5 because we write from least to greatest. And I would need a parenthesis around -1, and I would need a square bracket around 5. If you're feeling confident to try the next ones on your own, go ahead. If you want to keep just watching because you're starting to get it, but you want just some extra practice of me going over it, then just continue through. So the next one is x is less than or equal to -4 or x is greater than 0. So I need two numbers on here, -4 and then 0. And these are two separate inequalities. I have anything less than or equal to -4. I would need a closed circle here, and anything less than or equal to that would be to the left. The next one is anything that's greater than 0. I would need an open circle here at 0, and it would be anything to the right. So this notation is going to be, it's going to have more stuff going on because we have two separate graphs that need to be combined together. The first one, if I just look over here at this part of the graph, let's make this interval first. So this is technically pointing towards -infinity, so I would need that first, comma, -4 with a square bracket. And then looking at this part of the graph second, this starts at 0. It's not included, so I would use a parenthesis. And it points to +infinity, which I would need another parenthesis. Now, the technical way to hold these two things together is using a capital U, which stands for union. It pulls these two parts of the graph together with one solid answer. So that would be your notation. All right, and then the last one we have here is 5 is greater than or equal to x. So I know that I need 5 on my graph. And I also know that just from looking at the symbol, it's going to be a closed circle or it's going to be a square bracket graph. But I personally don't like to graph when my number is first. I like to graph when my variable is first. So to flip this around, I have to flip the x and the 5. And I also flip the sign. So since it was greater than or equal to, I would flip it to be less than or equal to. And then the answers would be over here to the left like this. The interval notation then would be -infinity to 5 with a parenthesis around -infinity and a square bracket around 5. So that's graphing inequalities using interval notation from an inequality itself. Now it's time for example 2 to start solving them. So in example 2, we have to still isolate the variables. The only thing with inequalities is that when we have negative numbers, if you have to ever divide or multiply by a negative, you have to flip the sign. I'll show you when we get to a problem like that. So the first one, we have z, I'm just rewriting it, z minus 4 is greater than 0. If it's helpful for you to circle the variable you're solving for, do it. If it's not helpful, don't worry about it. I just have to undo what's happening, so the opposite of -4 is +4. So I'm going to add both sides by 4, I get z is greater than 4. Your answers to inequalities will have a symbol like this. It won't be an equal sign, and for every inequality answer, you also need a graph. So here's what you would do to graph. You would just draw a number line. On that number line, you need the endpoint. Only thing I need on here from you is a 4. If you want to include more numbers, that's fine. This is going to be an open circle or a parenthesis because it's not including 4. 4 is not an answer since 4 is not greater than 4. And anything that is greater than 4 is to the right. So we have our inequality answer. That would be this. We have our graph. That would be this. And then our interval notation would be parenthesis 4 since it's not including 4 to infinity like that. So 3 separate answers for letter A and for every inequality that we have thus far. All right, B definitely is a little bit crazier. A, all we had to do was add 4 and we had our answer. This one, we have to distribute 2 times. So the first thing I'm going to do is multiply this side by -3. This is going to be -3y minus 30. And then I'm going to multiply this all by 4. Is greater than or equal to 4y plus 40. Now we have variables on both sides. It's up to you what you would rather do. I personally would rather add 3y to both sides, so I have a positive number of y's, but you could subtract 4y if you would prefer the y's to be on the left-hand side. It doesn't matter. I'm going to add 3y to can move them all to one side and see what happens. Those cancel out. I'm left with negative 30 is greater than or equal to 7y plus 40. All right. Now it's time to isolate the variable by undoing plus 40. To do that, I would subtract 40 from both sides. Negative 30 minus 40 is negative 70, so I get negative 70 is greater than or equal to 7y. Last thing I'm going to do is divide both sides by 7, and I get negative 10 is greater than or equal to y. It's fine that I have a negative answer. I did not have to flip a sign. You only have to flip a sign if you divide by a negative number or multiply by a negative number. So here's my answer. I personally would rather graph and use interval notation when these are flipped around. That's just my personal preference. So when I do that, I get y is less than or equal to negative 10 as one of my answers. The next answer, here's my graph. I would need negative 10 on here. It's going to be a closed circle since it's less than or equal to, and the answers are everything to the left. And then my interval notation, the graph is pointing to negative infinity, so that would be the first thing I write, and then negative 10 with a square bracket as my end of my interval notation there. Now, letter C, if you're feeling comfortable with this one, you can stop the video and try it, but just be careful. In this one, you will probably have to divide by a negative and flip the sign. If you want to just watch, that's fine too. Step 1. To solve this problem, which I'm going to write over here so I have a little bit more room, I have to undo the addition or subtraction first. This is 8 minus 3x, but this little negative symbol, this minus sign, is actually attached to the 3x. That's a negative 3x. So we have to get rid of this positive 8 right here. The only way to get rid of a positive 8 is by subtracting 8. Now I know that's a little confusing because this was subtraction in the problem, but this negative sign is attached to the 3x. That's a negative 3x. So you have to subtract the 8 to get rid of the positive 8 there. So I get negative 3x is less than or equal to 12. To solve this, I'm going to divide both sides by negative 3. Now, when you divide or multiply by negative, the sign flips. Here's why. If I have a true statement, I'm just going to write over here, like 2 is less than 3. You agree with that? I agree with that. If I were to multiply both sides by negative 1, let's say, then this becomes a negative 2 and this becomes a negative 3. This is not true anymore once I do that. That says negative 2 is less than negative 3, and that's not true. Negative 2 is actually greater than negative 3. On a number line, negative 2 is closer to 0. So whenever you divide or multiply by a negative number, you have to flip the sign in order for it to stay true, stay correct. That means that this answer is not going to be less than or equal to negative 4. It's going to be greater than or equal to negative 4 since I divided by a negative there. There's my answer in inequality form. Here's my answer in graph form, negative 4. Closed circle, anything greater than or equal to it would be to the right. And then my interval notation would be square bracket, negative 4, infinity. Okay, we're going to stop there, practice a few of these types of questions, and then move on to compound inequalities.